Nvidia recently it just break the 2 trillion valuations, and I think in terms of the record, right? Like for example, Apple and Microsoft, they took some time to hit that 2 trillions, but for Nvidia, it's just like within a couple of months, they hit from 1 trillion to 2 trillions. It's really rapid ascent. So if you look at the share price, regardless of when you buy it, even if you bought it like at the previous peak, now still quite big. So congrats to all Nvidia shareholders who profit along the way here. When talk about Nvidia and people keep on talking about the AI, right? So I think for most people, when we talk about AI, they will think of like ChatGPT, because for sure over the past 1 year, this ChatGPT is really like very hot topics. People use it to play around. People use it for productivity, all sorts of reasons. But this is the AI applications, or specifically generative AI applications as of now. But I think there are still, every week there are many new AI related topics or AI related apps that coming up. And some of these people may not know about it because it may not be accessible to everyone. So I will give one example. Is this video that it's called Sora by OpenAI. So I think some people who pay attention to AI, they will know about it, but I believe there are many people still don't know about this. So for now, right, I think it's not just text. Now all these AI applications, they can just from the prompt, right, you can generate video. And if you look at the quality here, it's really impressive videos. So imagine that everything that you see in this video here, right, is not real. It's all generated by AI. So this is where it is. And imagine that now in terms of like all these applications, right, it is basically at its bottom as of now. Like this is the starting point. You can imagine that after 1 year, 3 years, 5 years, how good this will be like, right? So I think this is the future of AI. That's why, because of even just some experiment, right? People see that, oh wow, AI can do this kind of thing, so impressive. And just imagine what they can do with this kind of technology 3-5 years later. I think this is the point that I want to bring up. Okay, so in terms of topics that I want to cover today, right? So I'll cover about Nvidia, the product, the business model, talk about the I'll start from very basics. I talk about what is GPU, and then talk about what is CUDA, and then the difference between CPU versus GPU versus ASIC. I'll talk about like Nvidia, the company, and then where they focus their resources on. I'll talk about their manufacturing, their competitive advantage, and the disruption, basically competitions. And lastly, I'll talk about Nvidia financials and valuations. So these are the topics. Let's start with Nvidia product and business model. Okay, when people talk about Nvidia, I believe even in the investment community, right, there are people who still think about Nvidia as like a gaming companies. So this is one of the most popular products, right, or one of the most advanced one. There are 4090 graphic cards. There are all sorts of memes, right, when people say that, okay, who's the happiest man on the internet? This is the guy. Because why? It's not about the girl. it's all about like, wow, he's buying like a PS5, Nvidia graphic card and so on. And this graphic card is not cheap. These are top of the line gaming graphic cards. Yeah, this is the Nvidia revenue breakdown. So if you didn't update your your data, right, and you just look at their financials prior to or up to 2019, right, you can see that most of their revenue indeed are coming from gaming, the red color one, the gaming part, right? But if you just look at what happened in recent years, right? So recent years, it's still the same chart. It's just that I extend more quarters where we covered like the recent 3 or 4 quarters here. Most of their revenue actually come from the data center, which is the blue color one. So the companies is no longer just a gaming company, but it is also a data center or AI companies. So this is the drastic change over the past 1 to 2 years. And in terms of data center, you can see that Nvidia really, they grab the market shares, right? Especially from Intel. You can see that for data center revenue, it used to be like 2/3 is Intel, but now you can see that actually 3/4 are coming from Nvidia. And this is the same chart, it's just that this is showing the absolute number. So you can see that from Q2 and Q3 and Q4 is even higher. This is not updated to Q4. Nvidia data center business is really like a lot higher. So now let's take a step back, right, to understand, because people who look at this, right, they will say that it's as if like Nvidia, Intel, they're all coming up with the same type of chip, right? But that's not the case, because for Intel, their data center business, right, is mostly CPU. So these are servers selling CPU chips, right? For AMD, I would say mainly still the CPU, but for Nvidia, it is mainly GPU. So they are very dominant. It is different type of server or different type of chips. So we need to understand what is the difference between these two. We need to go to a bit like go back to basics and to answer what is GPU. So to answer that, right, first you need to understand what is the difference between these two type of computing. One is what we call the serial computing, the right hand side one, and the left hand side one is what we call the parallel computing. Serial computing, right? I guess those who are familiar with like coding, right? Usually from the start, if you learn about coding, coding is all about like you write some codes and the codes run from top to bottom. It just run like step by step. So it processes line 1, then continue to line 2, 3, and 4. So it goes from top to bottom, and you have to calculate the above one. Then only you can move on to the below one. So it depends on the previous steps. So you go like serially. So this is why we call it serial computing. Okay. Then the second one, right, is what the parallel computing is that now instead of like everything goes like one depending on the previous one, parallel computing means that at certain stage, right, the computing works parallel. So it works at the same time, like all these 1, 2, 3, 4 streams here. It's still CPU doing the calculations. It's just that the type of computation is that it is done concurrently. So this is the difference between serial computing and parallel computing. So if you look at CPU and GPU, right, actually the difference is quite similar to this kind of different type of computing. So on the left hand side, right, if you look at the CPU chip, right, you can the compute part, right, the part that do the computations, right, is the blue part. So in this chart here, there are 4 cores here, 1, 2, 3, 4, and then under each of these core, right, they have their control, they have their cache, and so this each of these unit can do their computation. You can see that there are quite big portions is on the control part, this green color one. The benefits of having this control is that it is very, very flexible. Okay, that's why when computing just started, right, I think CPU is the one that lead the computing, because you want things to be very flexible. So there's big control part here. But if you go to GPU, right, you notice 2 things, right? One is that in terms of the compute unit, right, this blue color one, it is not as big as the CPU. So they are small cores, okay? Small cores means that in terms of the computing power, they are actually not as powerful as the CPU, okay? Second thing, you can see that the control, right, is not as big, because with all this, right, is mainly just doing the computing part, and the control part is like smaller portions here. What it means is that from the perspective of how flexible it is, GPU is not as flexible as CPU. And then one more thing to illustrate the difference between these two is that GPU, right, how it works is that all these different compute unit, right, it is engineered in such a way that they will do the computations on a parallel basis. So they are very fast because things happen concurrently. So to help you understand the difference between these two, I think this is some of the notes here. You can pause here just to read the details here. I'll say I actually not an expert on all this, but I think the important thing to note here is that when it is GPU, right, it is very, very good, because here built for parallel operations. Because if your codes, right, is not built for parallel computations, it's like what I mentioned, like in the serial computing, right, things have to happen after the other, right? So you can't really make use of the GPU. It's not an advantage to use GPU in that case. Okay, but usually in our computing, right, in our PC, for example, right, it is not like you choose one or the other. It is actually like, for example, my PC running here, right, actually have both CPU and GPU. It will work together basically. Some workload, definitely have to use CPU to run it, and then for those that can make use of GPU, it will pass to GPU. So that's how computing works. I think all PC have CPU. There's no way to get around it, because you need the operating system to run, right? So that one you need the CPU to run it. But how powerful is the GPU depending on the applications. So now think about it, right? In what kind of area that GPU is like really, really needed, right? Or think about it like GPU when it is first used. Like in what kind of area that people start to use GPU? Is coming up in the gaming, or coming up in the graphic, right? Or actually the full name of GPU is graphics processing unit, right? It is processing the graphic. Basically, if you're on your screen now, right, you're seeing this presentation and hearing me talking, right? The pixel on your screen, right? These are the graphics, and how all these graphics is projected, right? Is basically using the GPU. Okay, the reason why it is using GPU is because like there are many pixels, right? Like for example, the screen is like 1920 times 1080 pixels, right? So there are millions of pixels. All these pixels you cannot calculate and know what color to show by doing the computations on a serial basis, because it cannot project like one pixel at a time, right? It has to be calculated at the same time, and at every seconds it project things like on a parallel basis. Each of these pixel is a parallel computations. That's why when GPU was introduced, it is really meant for graphics, and it's meant for gaming, because gaming means that anything that you want to show on the screen, right, it has to be computed first. And then when you play games, things move, it has to be calculated and then projected to your screen, right? And that one you need a very strong GPU in order to come up with a nice realistic video. So this is why GPU, before all this AI started, right, it is really meant for gaming, meant for graphics, meant for visualizations. Now, how is this related to Nvidia, right? Yes, Nvidia is like one of the dominant company in the gaming business. And they are doing this mainly for gaming, right? And suddenly one day, right, Jensen or the Nvidia engineering team, they suddenly realize that, hey, this parallel computing or this GPU, right, is not just about like processing graphic. Actually, this parallel computing can be used in other area as well. That's the idea that suddenly came up. Okay, that's why from then they come up with this, what they call the general purpose GPU. Meaning that this GPU is not just meant for graphics, but it's meant for general purpose. So it's like closer to the CPU, whereby they want to make it flexible, but not just meant for graphics. They want to use all this parallel computing or the strength of the GPU in other types of general purpose workload. So this is the idea that they came by. Okay, just to run through with you like how it works, right? Is that this is the normal CPU, so it starts the processing, and then it goes to the data preparations. What he's trying to do, or how this GPU work together with CPU, is that some of the data will be uploaded to the GPU data, and then from the GPU data, it will run the computations. After that, you will pass it back to CPU and do the rest. So at least on the right hand side, right, is the GPU that is running. And when GPU is running, you make full use of all the parallel computing, right? So that's how you like accelerate the computing. Okay. So what Jensen is trying to do is that try to bring as much workload to the GPU, and try to make the GPU that they created as powerful as possible, and take on more and more workload from the CPU. And that's how you accelerate the computing. So this is the idea. And in terms of how they come up with this, right? So this is where we come into this topic about CUDA. So CUDA, right, is their platform or their programming language in order to execute this general purpose GPU. Okay, so this is the idea. If you want to understand how these things like piece together, right, you need to look at it like in terms of what are the layers in the programming models. So on the top, right, this is all the use cases. Like how can you use this general purpose GPU, right? You can use it for like consumer internet, industrial applications, for supercomputing. These are just different use cases. Okay, like before you take one step down, right, is that in order to make use of all this computing, you need to have some apps, right? Like for example, ChatGPT is like an app. So this is an app running, and this app running is serve different use cases. Okay, ChatGPT is one, and that's not the only one, right? There's still many other apps. For example, let's say if you use Photoshop, you use Adobe Premiere Pro, you use all sorts of software. So and you have your software, you have your framework. All this, right, will make use of this entire platforms. Okay, but this is the applications layer on top, and then below this applications layer, that's where you have all the software, the what we call the CUDA libraries, and also like the CUDA toolkits, their driver, and so on. Okay, so here it's a bit technical here, and if I also don't know how to like bring like try to explain all this, but it's not so important. You can think about of like this area, this tool, right, between this CUDA libraries, all these compiler things, right? They are the connections, right, between the applications layer, okay, your software, versus the hardware. Meaning, let's say if you are running on CPU or GPU, that's the hardware part. In between, right, you need to go through different sorts of like all these compiler, all these different cores, different toolkit, different libraries. It is like a bridge between these two, okay? And this tool, right, is the part that Nvidia is focusing about. This is basically their software part. But for now, I think Nvidia, they didn't really focus too much on the application layer, because they really work with other companies that come up with all sorts of like interesting applications which is used in different use cases. But their focus is to really create the best CUDA libraries, or like the best like all these compiler and so on, so that all these things, right, can work seamlessly with the hardware side. And also, of course, all these operating system platforms are involved as well. So this is actually the whole CUDA things. Later we'll come back to this to go into more details, like when we talk about the competitive advantage. Okay, on how this CUDA is used, right, is also they try to make it as simple as possible. Okay, so basically on the left hand side, right, this is the standard C code. So this is the coding. And then on the right hand side, this is the C code with CUDA extensions. How it works, right? I think, let's say if you don't know programming, let's say you are like me, I also don't know programming. You just need to see that, appreciate that it is actually very, very simple. You actually don't need to rewrite the entire code. Okay, that's definitely not necessary. You just need to, like go through the codes, right? And for those areas that you can make use of all these CUDA libraries, right? You will just use a function and just pass the necessary informations to the CUDA, and then from there it will just do their magics, use up whatever libraries that is necessary, and then it will just do the processing there. So they try to make it very simple for companies or software developers to make use of all these CUDA frameworks. So they want to, basically they want to eat into this CPU compute or CPU workload, and try to make use of accelerated computing stuff. Okay, this is how it works. Just zoom out a little bit, and just now we talked about the GPU, which is very strong at parallel computing. CPU, very strong at serial computing, because the cores are very powerful, right? And then there's also something that we call ASIC. We'll do just to show you this diagram to help you visualize or help you understand the strength and weakness between all these different type of chip. Okay, so on the left hand side, right, you have CPU, and I think Intel is still big on all these CPU, and then Nvidia is like very, very popular or very, very strong in GPU. And then of course you have ASIC here, right? This FPGA Xilinx, they are owned by AMD, right? This one I'll go into more details, but you can think of it in this kind of scale. So on the x-axis, right, this is the performance and power efficiency, meaning that if you go from left to right, all this chip is getting more powerful. Okay, very, very powerful. And then on your y-axis, right, it is how flexible and how easy to use. So you can think of it like CPU is very, very easy to use because it is very versatile, very flexible. You can do your programming, you can change your codes and so on, just to however you want to use the CPU, you can use it. Okay, so it's very flexible. GPU actually, it is less flexible. Or if you want things to be very flexible and you use GPU, actually you can't make use of the full power, because you want to leverage on their full power. You really need to structure your codes in such a way that the computation is done parallel, and not everything can be done using parallel computings, right? Because if your codes really, like I said, right, the serial computings, one step depends on the step on the previous steps. Actually, you can't make use of GPU in that sense, right? So you need to look at the types of workload, which are the area that things can happen on a parallel basis, and that's where GPU really shines. And then on the right hand side, let's take ASIC example, right? ASIC stands for application specific integrated circuit. By application specific means that this chip, right, when it is designed, right, you already know that it can only run like one specific application. Because some applications, they are very, very simple, okay? If it is very simple, you just design your chip such that it only meet these purposes, right? And you can scrap out all the rest, the stuff that is like not needed by these applications, right? By doing that, right, you can actually speed up your chips performance by, by 10x or 100x. You can actually do that. But the downside of doing this is that because the chip is really just meant for one application, if that application is like you need to change the applications, then you can't actually use. Basically, the chip become useless. You cannot reprogram the chip to do something else. So that's why ASIC, they're usually meant for, like some specific area and just very niche use case. You can't do it for general purpose computing. Okay, so basically this is like the trade-off between, like, if you want flexibility, then usually the performance isn't that high, and if you want higher performance, you will like give up some level of flexibilities. So this is the dynamics or trade-off between different type of chips. Switch gear a little bit. Let's talk about Nvidia as the company, right? Nvidia is now a full-stack computing infrastructure company with data center scale offerings that are reshaping industry. So sounds very technical, but let's unpack it a little bit, right? So by full pack, right, or full stacks, right, what is included here is, some of the stuff that I just covered. For example, like the CUDA programming model, the software libraries, the software development kits, and also the application programming interfaces or API. So full stacks cover all this area. Okay, then it accelerates the performance and eases the deployment of accelerated computing. When you think about accelerated computing, right, just think about like the parallel computing. Okay, how to make things run on a parallel basis so that it run faster. Okay, so this is the things. So what is covered under here is that, like artificial intelligence, model training and inference, data analytics, scientific computing, and 3D graphics. Okay, we will go into some of these examples here just to help you visualize. Let's try to understand a bit more on where Nvidia is in terms of the entire semicon industry. Actually, when we talk about semicons, right, people thought, okay, semicon is just like same as Intel, same as Samsung, same as TSMC. Actually, not the case, because each of these semicon companies, right, they do different things. Sometimes they compete, sometimes they actually work together as partners. So, and where Nvidia is sitting, right, is actually on the left-hand side here, and under what we call the fabless companies. Fabless means that they don't have their factory. Okay, they have totally no factory. They will work with their partners to come up with whatever hardware that they are selling. Okay, so all these on the left-hand side, right, these are the companies that only design the chip. Okay, they do not do the manufacturing. Okay. Companies on the right, which TSMC I covered in the past, or other, right, SMIC, UMC, Global Foundries. These are the companies that only do the fabrications. They don't design the chip. Okay, they actually take the design from the fabless companies or from the IDM, and then they just do the manufacturing. Of course, companies like Intel and Samsung, they have both. They do their design and also they have their own foundries. Let's talk about where Nvidia is focusing their resources, because you can see here, right, we just say that, okay, Nvidia only design chip, right, and they don't do manufacturing, right? Then, wow, design chip. Just, like we're talking about 2 trillion companies only do design. It sounds like a bit like hard to imagine, like what does it mean by designing, right? So yes, actually they are only focusing on 4 things, right? Okay, the first one is designing the chip. Okay, we'll go into that in more details. Second thing is they ensure that they do the quality assurance. Okay, quality assurance on both, like the manufacturing on the chip and also some others, the hardware side now. Okay, they do the QA. Like for example, sometimes customer complain about their GPU cards. So let's say GPU cards, gaming cards got problem. So Nvidia have to go into it to like investigate, and if the supplier have some problem, they need to sort it out with their suppliers, right? So they do the QA. Okay, but they outsource the hardware side, the hardware manufacturing. The third one is basically marketing. They do like marketing, advertising. So this is definitely one of the key focus. And the last one is the support. By support, this is actually big. So they have like thousands of engineers, right? All these engineers will work with the engineers in their client, in their customers, and work together in terms of like how to help them make full use of whatever Nvidia is able to offer from the software side. So this support is actually quite a big one. Come to chip design, right? Actually, chip design, this is, we're not talking about like, you know, those low level chips, right? These are highly complicated chips, right? And if you zoom into each of these chips that they're making, right, actually it looks more like the cities, you know, like cities planning. Like you zoom into all this, I can't zoom in here, but if imagine that you zoom in, right, in terms of how the things flow, right, actually is very, very complicated. And I think even Jensen also mentioned, right, this when they design all these chips, right, because you need to let the circuit flows, right, and now they are already at a level such complexity that even humans find it difficult to do all this designing. They have to pass all these designs, some of the things, let AI do the things, you know. So they really need, like, it's very, very complicated, so basically. So this is their focus, basically design the chips, okay? Just to give you some idea, right, on how difficult it is, right, to design a good chip, right? You just think about this. I don't know whether you follow Apple. And Apple has been designing their chip for quite some time. So say for example, now you are using iPhone or iPad, right? They call the, you know, the Bionic chip, or they call the M3 chip. They design their own MacBook, right? So this is the logic chip that they're having, and they design all these chips themselves. But when it comes to the internet modems, right, the communications chips, right, actually they're still using Qualcomm's chip. They already work for a few years to, you know, like in-source this part instead of relying on Qualcomm. They want to bring this into their chips so that they have more control, right? And they have been, like, you know, spending billions of dollars and working on this for years, right? But still they are not able to replace Qualcomm's. Okay, one reason is, like, of course, the IP protections, they can't just simply copy, right? So that's one. Second thing is, like, it is simply not easy. By not easy means that maybe a crappy one they are able to churn out, right? But a crappy chip, sometimes it overheat, sometimes it doesn't perform as well. So these are the things that they need to, you know, make sure it is at least on par with whatever they try to replace, right? In Apple case, they really need to, you know, push back the plan to at least now to 2026, right? Because it is like they fail basically to you know, like transition to their own communication chip. So this is just one data point to show you that even when it comes to designing the chips, right, it is not easy. So this is basically what they do, like they are the core business. When we talk about the chip design, it's not just the chip design, right? So the chip design is one area, because they have to design it and then pass it to, let's say, like TSMC to manufacture, and then bring the chip in and build their, you know, like their hardware, their data center machines, right? That's one side. The other side is, like, they spend a lot of resources to build all this, you know, like all these CUDA things, all these libraries, because they have to look around, right, to see that, you are doing this piece of workload, and how long do you need? For example, the company A doing certain things, and they say, they need to run for, like, let's say, like a week for that. Basically, if you take 1 week to run that things, the first thing to look for is that whether that things is it, right, really you need to run things on a serial basis, or can it be like on a parallel basis, right? So if it is parallel basis, that's how Nvidia spot opportunity and say, if I can, you know, come up with some sort of library, and then if you make use of my chip, right, GPU, and these things, instead of you take 1 week to run it, now it just take 1 hour to run it, right, because of how powerful is the GPU, right? So they have to come up with software to help all these companies to you know, like onboard to this accelerated computing things, right? So that's why they have, like, spent a lot of resources to build anything that's necessary, so that they can take on more workload. Okay, and it is true that if you follow the progress, right, more and more workload, as long as it can be done on a parallel basis, right, they will go to this accelerated computing, just because of, like, the time saving, the power saving, the energy saving. There's a lot of benefits, right, when you can run things like, you know, like 10, 100, 1,000 times faster. So this is basically their resources on the libraries, on the software side. So this is their core business. All right, now let's talk about the manufacturing supply chain. Okay, just now we talked about the fabless and foundries, right? If you think about it, there's again, like, the four quadrants, right? Companies like TSMC and Samsung, they do the foundries. definitely this is their key Nvidia key partners. They also procure memory from like Samsung, Micron, and SK Hynix. This memory, although it's like maybe it's called like DRAM or all this RAM, right? But when it comes to all these data center class, right, all this memory class is like totally different. It's like enterprise grade, what they call the HBM memory and so on. So they need to buy like the memory from these suppliers, and they need to get a TSMC to produce the GPU chip, and then they have their contract manufacturers, meaning like Foxconn and Winstron. These are the companies that help them piece together all these chip, memory, motherboard, all these things pieced together. And then of course lastly they have companies like Fabrinet that help them do the assembly, the testing, the packaging. This is the suppliers. Pay attention, all these things here, right, like 1 2 3 4, right, these are all the hardware side. Hardware side is like everything. They rely on their suppliers, their partners to do this piece. They Nvidia really just focusing on the software side. So and that's enough for them. Just want to highlight to you that there are like quite a long list of partners that work together. So that's how it works in their area. Okay, now let's talk about competitive advantage part. Okay, I think this part, right, if you just read articles, you will notice that this part isn't that obvious, or people don't appreciate much about the strength of Nvidia. The first one I want to highlight is the long-term usability of their GPU. Basically, the analysts asked Jensen, your customers, right, they are spending billions of dollars, right, or at least on hundreds of millions of dollars, right? They buy your GPU now, and we all know that all these GPU, right, after 1 year, after 2 years, definitely there will be another versions that coming out that is even much better than the previous one, right? So is that means that customers spending hundreds of billions of dollars, and all these, like all these H100 chips, it will become useless like just 2 years, 3 years down the road? Is that the case? So how durable are these chips, right? Basically that's the questions. Jensen's answer is that very interesting. So I would say that he gave some historical context on all this, right? So basically when it comes to like all this CUDA and Nvidia, how they run things is that whatever they invented in the past, right? So imagine that this is all the software, right? So they have a very strong pillar. This is the framework. Everything needs to fit into this pillar or this framework. Okay, when you invest new things, you need to be very disciplined and fit into these platforms. They want to standardize things basically, so that as you build new things, right, the old hardware that make use of these standards, right, they can make use of all the new innovations that coming out. I know this is a bit abstract, but let's think about it, like think in inverse, right? Like how does it looks like if the company don't have the discipline to fit things under a very standard and do it on a very disciplined manner? So for example, right, if a companies, right, software companies, their customer just, they have like, let's say 100 customers, right? And each of these customer, they just say, oh, I want different changes. Like can you customize this functionality for me? Do this and do that. So if you take a shortcut, right, actually what you do, right, is just that you just, okay, I do this, customize for you, customize you for this, and then customize this, customize that, right? So end up, right, the codes, right, the software, right, they will be very all over the place. Okay, when that happen, right, say for example, when you have new technology that come out, you build certain things that is new, right, and you can't make all this new software port over to those like old source code, old codes that has all sorts of customizations. Because if there are too many customization, it's like very messy, and then every time you have new things that you want to onboard, right, you have to piece together, and from the software development perspective, right, this is super messy. But I would say that at least for Nvidia, right, they are very, very disciplined when it comes to this, so that they maintain the core, and that core, right, is serve the current install base, and it will serve the future. In the futures, as long as new innovation come up, they can still make use of it. So this is the strength of the companies, because you really need like discipline to maintain that. Like let's say if you are customer, you buy GPU chip H100, right? You don't have to worry so much about like all these chips become redundant in the near future. Basically, you can still use it as there's new AI coming up, new model coming up. You can still use as long as all these fit under the CUDA platforms. Then it will stay useful for very, very long time. So this is why they are not afraid, right? And when we talk about the GPU versus other types of chips, right? GPU, you're still able to reprogramming it. So I think that's the strength. Basically, you are not afraid that when model change, you need to, like, your chip become useless. You don't have to worry so much about that now. So I think that's one key strength. Okay, I know that my explanation here really sucks out on this part because all these things, right, when we talk about like software developments, right, I'm definitely not like the expert, but I just want to bring out the point that these are the underrated stuff because you need people who are in the software development world, right, in order to appreciate the discipline, right, is very, very important. Let me read a couple of comments here. But managing tech complexity through a defined tech architecture and the roadmap is not unique to Nvidia. Yeah, I do agree on that. I think the way to do it, right, like this, right, I don't think it is that unique about Nvidia. So I think the unique part, right, is all about the execution part, the implementation part, because you can come up with all these, architecture, but when it comes to actually running it, if you are not disciplined, you just do things all over the place, right, and just to fit your specific customer needs, right, then really things will become messy along the way. But I would say, relatively speaking, NVIDIA is quite disciplined. I think this is also because in the past, right, imagine that they invented all these CUDA things like more than 10 years ago, right? When it comes to your use case, right, actually it is not like there are thousands of use case. Actually, it is very, very niche, okay? And by niche is that they don't have like huge customer base. They just work with a few customer, and even that few customer also when it comes to the type of computing is also maybe quite similar. So that's why they have this discipline to really do something that fit all these a few customer, right? So they have the time and resources to do things on a discipline and do things the right way. Because if you compare Nvidia versus, for example, like Microsoft, right? Microsoft from the start, they have like thousands, hundred thousands of different software developers and then different customers. So they roll out to all these different type of customer, and they all want different things, right? And so naturally, there will be pressure to do many things just to fit different type of customer, and then things will get messy like very quickly, and it's very hard to just bring things become a lot more on a disciplined manner, because all these things that you need to fix, right? Say for example, let's say suddenly Microsoft know that they have to invent a new architecture and streamline everything, but very hard to do for them to pull that off, because things that are running currently, their current customer, they are using all this Windows platform, right? They are using it. You cannot just come up with something new and just say that, okay, now everything need to fit under this. Basically, all the stuff that is running now, like you have to fit into my own new rules, which is more streamlined. So they don't have this kind of luxury because now the planes, right, is already flying, right, and now you are inventing new engines when the planes is flying, and fix the engine at the same time, right? So for these companies, I would say it's a lot more difficult. It's not about like the quality of their engineer is bad or like that. It's mostly because of like diverse customers, and then they just don't have the luxury to streamline the things. So I think this is one key strength that Nvidia have. Okay, let me just read a couple more comments here. From Sean, if Nvidia face more competitions from other providers, will betting on chip manufacturer or suppliers like TSMC be a safer long-term bet on AI push? But this one very interesting question, Sean. I would say very different dynamics. Because for Nvidia, if you think about it, if you want to bet on Nvidia, you need to understand their strength. Their strength is basically on the software side. And specifically on the software side, right, is the platform. Platform meaning that now, what is on the platform, right? Take a step back, okay? On the platforms, you have all these, like the software developers that create all these different libraries, and then you have their customers who are using all these libraries to create their apps. On the platforms, you have Nvidia engineers that design new things, and then try to make sure that all these libraries will be able to connect to the hardwares and make use of the new hardwares. So this is like the entire platforms, right? There's flywheel inside this platform, meaning that when there's more customers that are buying Nvidia chips, and then there will be more developers that come onto the platforms to do like create more libraries, create more apps, and then those apps is not just their own apps, right? They can work together with other apps. So it's like a platforms that is like the more people join, the richer it is, and then the harder it is for the existing customers or developers to get away from the platforms. So this is the strength. When these strengths, these things will keep on flying, and if there's competitions from the other competitors, even if they design like a faster, cheaper chip, right? Actually, the customer can't get away. Because if they get away, they need to redesign all the software, redesign all the libraries, the compilers, and so on. So to redo all these things, right, just like there's too much effort. So they're stuck, basically. They're stuck with Nvidia. So that's the case that when you talk about like how strong it is, right? If you can appreciate this piece, you know that this flywheel will continue, then you don't have to afraid too much about the cheap competitions from other competitors. Now, go to TSMC. Yes, they are in the same industry, but definitely is very different in terms of the dynamics. For TSMC, I would say that their competitors are, like Samsung, maybe you want to say SMIC and so on, right? So these are their competitors. I would say that for TSMC, there's no, it's not about the flywheel, like what I just mentioned, right? There's no flywheel there. What they have is they have a lot of volumes, and that volumes will bring them benefit in terms of cost advantage. I don't know, suddenly things are flashing. I hope that doesn't affect the streaming. Okay, the next one is, there's these questions that ask about the adoptions of all these accelerated computings, right? And one good example given by Jensen is the recommender system. You can pause here to read. What Jensen is trying to explain here is this, right? So you have all these big data center, they're super powerful, they do all the AI, the fancy stuff, the accelerated computings. These are big data center, super powerful. But at the same time, on our hand, right, we are holding a phone, right? So we are holding a phone. Everything need to fit into our phone for us to consume. Whether you are, like watching this video or you are watching TikTok or whatever, right? Everything we have to fit into like a very small package, okay? And how this big data center fit into like small phone, right? Is that you cannot just download everything into the phone, right? What happens is that what is being fit into the phone, right? There's these things called the recommender system. Basically, they need to run AI to see what to recommend you so that you stay engaged on, for example, Facebook or TikTok, right? You need to stay engaged. And these recommender systems is all built based on like the chips that's powered by Nvidia, because these things keep running on a continuous basis, and you cannot use CPU to run all this because it's just not fast enough, okay? So we really need GPU, and this is basically things that's powering recommender systems. One good example is the Meta, right? After the privacy is being cut off by Apple's, right? So they say, oh, you cannot tap on this user data and so on. What they do is just that they buy more Nvidia chips. They buy all this recommender system. They call it like AI, but actually it's not like really AI, right? Yes, it is AI. It's just that the core things about that is just that, okay, now instead of using the specific data from these specific users, I just need to make use of whatever that I have on the data, which is like a lot less compared to the past, and use that data and just run a more powerful recommendation algorithm and use a more powerful engine to power it, and basically just use recommender system to come up with something that will work in terms of like pushing the relevant ads to the users. So this is one use case only. Companies like Meta actually spend billions and billions just to make sure that they have very powerful recommender systems, and they are definitely one big customers of Nvidia's. So this is another one example. Okay, the other thing I want to mention is that the speed of innovations. Okay, this is the graphic, and you can see that now actually I think the most powerful now is H200 that they are selling, they are ramping up. Just before that, H100 is also Nvidia chips that's like selling like hotcakes. Actually, the A100 is also like people, companies that bought all these A100, they are still using all these chips, right? So this is the past. I believe the B100 will come up soon. At least they will announce it in the upcoming GTC. Probably by end of the year or maybe next year, you will see that B100 will start to ramp as well. So and one thing to highlight from this chart, right? I know it is quite there are a lot of things and we don't have to go into that details, but just pay attention to the cadence, right? The speed of them rolling out new chips, right? You see 2021 is A100, 2 years later is H100. They take like literally 1 year and then suddenly come up with the H200. Within like 1 year or less, right? They come up with B100. So all these iterations, right, they don't take like 2-3 years to come up something that's new. They really come up with new things on like every 6 months. In terms of hardware, maybe I would say one or 1.5 years. But when it comes to all the libraries or the software side, right, it's really they come up with all these innovations or iterations every 6 months. So it's very, very fast. They actually speed up their cadence to make sure that they stay at the forefront, and they speed up the adoption as well, and not just they are already the best, and still this is their imagine this, right? This is Nvidia, this is the competitors that's trying to catch up, right? Just imagine that Nvidia is like, let's say 20% higher than the next best competitor, but the speed, right, actually is faster, meaning that now imagine that they are 20% faster. Maybe 1 year or 2 years down the road, they are 30 or 40% faster. If you think about it, it's like almost impossible for the next competitor to catch up. So it's really, really hard. I would say it's not like I'm saying that the competitors will go out of business. It's not like that. It's just that I think the smart one, like in terms of those doing similar business, say for example, designing chips and so on, if they are smart, right, they are not going to be like go head on with Nvidia. So, but they can always look for, like specific niches and work on those specific area. And at least in those like small areas, right, they can, and have better products or better services as compared to Nvidia. So I think that is definitely possible. But the big markets, right, I would say that Nvidia will still be the dominant one, just because of like how good they are, and how fast they are at coming up with new innovations, and coming up with better chips, of course. Okay, speaking of GTC, the upcoming one is in about 3 weeks' times. The 18th of March. So for those who follow their GTC, I've been following their GTC for a number of years. I would say that very fun to watch all these shows, like what are the new things that they are working on. Say for example, few years ago, they come up with GTC, and then there's like music on the background, and then by the end they just say that, oh, this music, this background music is constructed by AI. Stuff like this that is like interesting. Like okay, they really make use of the stuff that they are powering into their marketing, into the showcasing part, like they show that, oh, they are powering all these innovations. The most recent one is of course all the generative AI applications, and more will be coming out, right? So looking forward to this event. So bookmark your calendar, or if not, just come join the Telegram group. If you watch this and you click, please, I'll PM you just to make sure that you are human, and then just let me know that you just get the Telegram link from the YouTube, and then I will just add you to the group. We will have discussion inside the group on all the new announcement coming from Nvidia. So definitely looking forward to the next GTC. Okay, next let's talk about the disruption. Okay, the competitions part. So one thing I noticed, right, is that at one end, Nvidia, they come up with all this GPU chip. Of course, the closest competitor will be AMD, because AMD just, they have their MI300X chip, right? So they try to compete for sure. And then on the other side, right, these are the hyperscalers, right? Maybe except for Meta. So on AWS, they have their Trainium chip and inferential chip. And then Google's, they have their TPU. And then Microsoft also announced that there's this Maya 100 chip. And then, of course, even Meta also try to design their own chip, right? So they call the Meta Training Inference Accelerator. Even other companies like Apple also, they design their chip. They also try to make full use of AI and so on. If you look at hyperscalers, right, and other companies, quite a number of them are designing their own chip. It's as if like everyone is trying to compete with Nvidia. And if you look at the comments, right, this is also a very funny one. Like they interview interview Jensen and ask him like, which competitors keep you awake at night? So this is quite interesting. Let me read it up. The TPU team is extraordinary. TPU is the Google teams. The bottom line is the TPU team is really great. The AWS Trainium team and the AWS Inferential team are really extraordinary, really excellent. Microsoft has their internal ASIC development that's ongoing called Maya. Every cloud service provider in China is building internal chips, and there's a whole bunch of startups that are building great chips, as well as existing semiconductor companies. Everybody's building chips. But the interesting part is this, that shouldn't keep me up at night, because I should make sure that I'm sufficiently exhausted from working that no one can keep me up at night. That's really the only thing I can control. So I think that's quite interesting. But it just shows that almost everyone is building, like designing their chips. And specifically, if you look into the details on these chips, right, that just mentioned, right, they are not similar to GPU. They are closer to the ASIC, okay, the application specific integrated circuit. So they are closer to the to this side. And the other one that is recently become quite popular is the Grok chip, right? For those who don't know about this, you can go to this grok.com and try out and to see that how fast like they are running all these different running the inference. So and Grok CEO, he says that most startups will use speedy LPU by end of 2024. The LPU is basically their chip, which in terms of the architecture is slightly different compared to Nvidia GPU. And if you go to their website, right, just type up your prompt, right, and this one is running the Mixtra model, and it's really fast. It's like you type it out already, the stuff that come out, it's very exciting. It's like, wow, think about it, if you just use this, you think that, wow, then is that means that Nvidia GPU is slow, is useless, and so on? You say, hold on, okay, not the case, okay. One first things to note is that this is running the Mixtra 8X7B model. This is actually a much smaller model as compared to, let's say, GPT-4, okay. So the type of model is different, okay. I'm sure that, let's say, you use Nvidia GPU to run this smaller model, also it could be faster, okay. And second thing to note, all this, right, this Grok or all these I call the ASIC, right, like closer to ASIC. Sometimes it is not like just like pure ASIC, sometimes it's like in between, right, meaning that it is not as flexible as Nvidia GPU, but because they want to get the performance, they want to get the power efficiency, they will move towards the right hand side here. And what it means is that all this chip, right, is actually not as flexible as GPU. But companies still invest money because these are the hyperscalers, right? They have tons of workload, right? So if they are designing their own chip, and then they know that, okay, if I design these things, even if it just run these specific applications, but still I don't have to worry about that because I still have tons of workload that will be running these things for years ahead, right? So that's why it makes sense for these companies to design their ASIC so that they can save some cost. But the things that is running on the forefront, right, the latest model, the stuff that require the best computing chip, right, they will still have to, like, fall back to Nvidia, because only Nvidia with the flexibility of the programmable features, right, can really run the latest models or latest software that they're coming up now. So that's why I would say that yes, it makes sense for these companies, makes sense for them to do R&D on this area and design their chip to save costs and to bring things in-house instead of like everything need to rely on Nvidia. It makes sense for them to do so, but actually they are unable to compete with Nvidia. So basically that's the explanation that I have. But yet, my visibility is only up to, let's call it like, let's say 1 year to 2 years, right? We still don't know, like, could it be like one startup that none of us heard before that suddenly come up with a GPU that's even better than Nvidia? The answer is yes. I mean, anything is possible. It's just that I have very high confidence on Nvidia, not because like the quality of their chip. It's not because their chip run faster. It's all about the CUDA platforms that they have built. The flywheel effect is a lot harder to replace now. So that's the short conclusions. One short quick note about US-China ban. I know that actually this is not big, at least for me, okay? Because if you look at their recent financial, right, actually it's just like mid-single digits come from China. But again, like US-China, there's some ban in between. So Nvidia actually they have to pause their shipment to China and then redesign their chip to make sure that it passed the guidelines. And still in the recent quarter, they can't sell that many chips to China. So they have some problem there. But I found that this answer given by Jensen when analysts asked about this, right, is very, very interesting. Okay, so this is the part, right, that I highlighted here. At the core, remember, the US government wants to limit the latest capabilities of Nvidia accelerated computing and AI to the Chinese market. And the US government would like to see us be as successful in China as possible. Within those two constraints, within those two pillars, if you will, are the restrictions. So very interesting. Thing about it is that it's not like US government want Nvidia to get out from China. That's not the case. Okay, they just want to make sure that their competitors in China, there are still quite a number of startup in China that can make use of like the latest technology from Nvidia to create powerful things, right? And those powerful things could be things like related to defense, right? So definitely US, they want to limit that, okay? But still, Nvidia is still a US company. It doesn't make sense for the US to limit the markets that Nvidia can serve. So that's why between these two pillars, meaning that they want to have some restriction, they want to block China. At the same time, they also want Nvidia to be successful. And so how to juggle between these two pillars is that they have to come up with some restriction. They have to have some consultation to make sure that whatever Nvidia is shipping to China is something that the US government is comfortable with. Basically, this is where they are. Okay, so I think this is quite interesting because I think this is the first time that I heard that someone mentioned that actually US government want them to be successful. Let's not forget about that now. Okay, so that's just a quick note. All right, let's go to the next one. Let's talk about the financial and valuation. Okay, my kids at the background there, so very noisy the moment they open the door. Okay, let's come back to Nvidia financial and valuations. I purposely put this one at the last section because I think that when it comes to financial and valuations, right, let's admit that we can look at the result today. You can try to guess the results in next year or the year after that, but actually no one knows where's the financials and financials keep changing anyway. But the stuff that is not changing, right, is the stuff that I just mentioned in the beginnings, like all this. You understand the strength of the flywheel of CUDA and the strength of GPU and where are their markets moving forwards. I think those are the areas that, let's say, just 6 months from now, these are the things that are still relevant. Whereas for this last part, right, talking about the financial, right, these are the things that after 6 months is all like outdated. Not even like 6 months, maybe 3 months is already outdated, right? So I purposely put this one till the end. But still, I think for now it is important, right? So we'll go through that, okay? Okay, if you look at their financials, right, this is the Q4 income statement. Pay attention to this, right? The largest segment is the data center. They have 18 billions of revenue coming from the data center. Gaming is about 3 billions, and the rest are very, very small, okay? And if you look at their how much of all this revenue actually flow to the gross profit and operating profit and net profits, right, they are very, very big, okay? Basically, just to say that the company is making tons of money, okay? Okay, let's go back to the last 12 months revenues, right? You can see that the 12 months revenue, it just like go up, and then there's corrections here around end of 2022, and then since then, once the data center business picked up, right, you just see that all this entire thing just skyrocket, right? So on a last 12-month basis, right, you need to remember these numbers. The last 12 months, right, the revenue is like $61 billion, okay? Out of these $61 billion, just the recent quarters, right, is like 22 billion of revenue. Okay, this like their revenue really going up like crazy. Just one quarter before it was 18, and the quarter before it was like 13. So you can see that it's huge growth in their revenue. Okay, then next quarter they guide 24 billions, and remember that on the most recent quarter they actually guided 20 billion and they exceeded that by 2 billions. When they guide next quarter is 24 billions, I won't be surprised, let's say they hit 26 billions. Okay, sometimes they send back a little bit just to make sure that they beat on their earnings. Okay, and then I think the surprising part, which I also a bit shocked when I look at this chart. Okay, this chart, right, is showing the revenue consensus, the average consensus revenue for the next 12 months. Right after the earnings release, right, all these analysts, they update their their forecast. And this forecast we are talking about like next 12 months, right? Next 12 months, how many how much revenue that they are able to generate. And if you look at just these numbers, right, now they are already 24 billions, right? So times 4, that's about like 96 billions. When it comes to consensus, right, it is not like all these analysts are projecting a flat, right? They are projecting that it will keep on continue to increase, okay? It's not 96 billion, basically, it's like 110 billions. So as the analysts continue to update their forecast, right? You know, like their forecast 50 suddenly becomes 70, suddenly become 90, now suddenly become 110. So this is basically what is driving the share price. Because first you have the revenue. From the revenue, you will have your operating profit, your net income, your free cash flow, and the free cash flow is actually the one that's driving all the share price, right? So now, you know, they update their outlook, and just remember that now they upgrade their outlook up, right, doesn't mean that this is like forever up one. You see, during the period where there's some, you know, like recession in terms of the sales, right? Sometimes all these analysts, they also reduce their expectations of the sales, right? So sometimes it's up, sometimes it's down one. Okay, just remember on that now. Okay, now let's look at the operating margin. Just remember this one number because we'll use it later. The operating margin is about 54%, okay, right now, and it's like historically high. This is another numbers which is important. This is net profit margin. Right now it's like 56%, okay? But pay attention to this, right? It looks good when they are generating 56%, but this 56%, right, is unlike, you know, like companies like Apple where their profit margin is very, very stable. In Nvidia case, right, the profit margin can go up to as high as 56%, and not too long ago it was like 10%. So it's zigzagging from, you know, like 10, 39, 16, 39%. Even recent years, don't talk about the time before that, because the mix of the business also different, right? Recent years also it can go up and down one. So for example, right, let's say over the coming 2 years, if the supply is catching up to the demand, right, I don't think they can keep their so-called this H100 chips at such a high price. Of course, they have to lower the price to induce more customer to buy the chips, right? Once they have enough supply capacity. If that happen, right, they have to adjust the pricing, and definitely the profit margin will be affected. So I think that's why I would say that the reason we don't just look at PE, because the moment you look at PE, you would think that, oh, PE, the earning, is it fixed? I would say that no. Okay, because the earning depends on two things. One is the revenue, how much growth that they are generating, and secondly is the profit margin. And for Nvidia case, the margin itself is like go up and down, okay? And the growth, of course, also up and down. You see the growth, right? In the past, let's look at the quarterly growth, right? You see it can go up as well. This is not a company that when it comes to their product, every quarter is showing, like growth. So in semicon sector, even the growth, right, the sales, right, is volatile. Let's talk about the forward PE. One thing to note is that, right, although these companies, people are saying that, wow, these companies is overvalued, it already went up by, I don't know how, 200%, it's overvalued. But let's be fair, if you just look at the PE, right, the PE is, this is forward PE, is like about 32 times, okay, at least from Coifin, okay, 32 times PE. You can say that it is fairly valued or somewhat overvalued, but it's not super overvalued. It need to at least be above, let's say 50, to call it like overvalued, right? So 32 compared to historical is also, like, I would say, quite fair, you know. But in terms of how much investor is paying for the earnings, right, the forward PE, right, also fluctuate around between, let's call it like between 25 to about 55, okay? So this, even the PE itself also fluctuating. Okay, then you want to ask, right, like if given the earnings, how much are you willing to pay, right? So that's questions that everyone need to ask. Okay, now we have the numbers already. You have the margin, you have the revenue, you have the forward PE, everything. Let's piece all this together into the valuation, so that we try to come up with some valuations, basically. Okay, this is at least my own view. Again, this is not buy or sell recommendation. This is just my valuations, the current moment. What I did is that I pull out the recent numbers. These are the recent revenue, and I just use the revenue versus the operating income. These are my basis. Okay, then I have 3 case, bear case, base, and I will also have a bull case. And then inside here, I just put in the margin. Okay, and then I put in the growth. Just from this, just do some multiplications and project the cash flow and discount back at 10%. I have an exit multiple of 20, 30, 40 for these 3 different cases, and then just do my calculations, and boom, I have the numbers. Okay, base case to me, fair value 840, bear is 300, the bull case is 1300. This is my numbers, but there's a lot of caveat from here. Okay, first things is that when it comes to the base, right, the reason I put in 80% here is that at least I think when it comes to analyst estimate of what's going to happen in the next 1 year, right, I would say that it is they are quite accurate. I do believe that they are able to generate about 110 billions dollars of revenue. Okay, but the year after that, that's the part that, okay, it's all over the place now. For now, I just put in like 18% growth on the subsequent years, and quickly go down to like 10% every year. So it's not like It's not like super bullish kind of it's my base case basically. So I think this is fair, at least for my base case now. But for the bear case, right, I just put in like, instead of 80% growth rate, I just put in as like 40%, basically just half, okay? And then, of course, for bull, I just jack up a little bit. So this is the growth. And then for margin, on the bull one, I don't think that they can keep on pushing up. I just put on like 60%. But for bear, I reduce it to 40%, okay? And then in terms of exit multiple, you can see the average is about like 30 is fair. So just bull and bear, just put the 2040s, right? This is the fair value or the DCF that I try to do. One thing to note is that the range is super big, from the low to the high is very big. The reason is because it really depends on like the growth, right? And the growth, the high one versus low one could be very high. The thing is that we just need to admit that we don't know. We don't know how big is the market. We know that every time everyone is exciting about AI, everyone want to buy more chip. They want to roll out their interesting applications. They want to increase the productivity and so on. That's all true. The things that we are not sure is that not every companies can spend billions and billions like Meta or like Microsoft and Amazon, right? After all these big companies buy their chips, are the smaller companies able to fork out the type of like hundreds of millions to buy all these chips, right? Again, they are not cheap, right? So it's quite expensive. And I also think that maybe even they are able to sell more cheap if the pricing wise they have to revise now. So that will hit their revenue as well, right? So there are a lot of uncertainties when it comes to the growth, and also there's a lot of uncertainty when it comes to the margin. Okay, that's why the range is super big. And one thing is that if you remember, right, for those who watch my previous video when we have all these talk about sing song, right, and I just saw this on my spreadsheet, is that I did this kind of valuation before. This is like just 1 year before, okay? At that time, Nvidia result was like essentially at the bottom, and their revenue is about 27 billion on last 12 month basis. Now it's like 61, right? So it's about like slightly more than like go up by 100%, right? Okay. Back then the margin was like 16%, and I asked myself, what is my bull case, right? I would say, okay, I think that they can go up to 25-30% after that. I didn't saw that they can go up to 60%, right? So even I try to come up with a range, and still the result can fall outside of the range. So you see that's how interesting it is. And when it comes to revenue, I thought that they are able to generate, let's call it like 60 billion of revenue, but I thought that it would take 3 years for to grow from 27 billion to 57 billion. 1, 2, 3, maybe 3.5 years, but they took like 1 year. So you see, it's very hard to predict what is the revenue. So I won't be surprised, let's say under a bear case, this is not bear enough, like let's say their margin fall back to 30%, growth fall back to, let's say, like just 0%, no growth at all. So those are all possible, right? So you can do extreme bear scenarios. It's up to you on how to do that. It's just that by having this kind of calculations, we will know that, okay, under today prices, right, which is like close to about $800, right? The assumptions that has been priced into it is close to this base case here, meaning that the market is already expecting the company to generate about $110 billion of revenue over the next 12 months. So if they just able to generate 110 billion, that just meet the expectations. It's not like a positive surprise, right? So that's why I say, yes, it is not too far from fair value, but in terms of the assumptions, many optimistic view has already been priced into the share price already. So that's why if you invest into Nvidia now and hope for just 2x 3x your investment within 2-3 years, I would say that is unlikely. Okay, it's very different compared to 1 year ago, whereby 1 year ago you ask people to come up with some projection. They don't expect that the companies will grow to $110 billion of revenue, right? So it doesn't make sense to have that kind of projection back then. You ask analysts, they will say, what are they selling? How can they reach 110 billions in 2 years time, right? But now, because of all this product that they're coming up with and all the AI excitement, yes, they are on track to 110 billions, right? We see there's visibility to it. That's why this part is already priced in. It's a lot harder to have outsized returns at today's valuations lah. But still, I won't say that, oh, because of all this fairly priced, so should I sell the stock? To me, it's like I don't think so. Yeah, because for me, the important one is not about the next year. It's more about like holding to these companies for a long period of time and just ride on this trend, right? And we have Gilbert here. Gilbert, I don't know if I recall correctly, is already what 30x or 40x return on Nvidia, right? So he has been investing in these companies for many years. So and I think what I try to do is similar things, which is like, okay, looking for good companies, looking for companies that have all this flywheel, strong mode, have competitive advantage, and just holding to these companies for a long period of time. So that's my approach when it comes to investing. And right now, Nvidia is definitely my highest in terms of the allocations, but I'm not adding now. So at least that's my approach. Alright, this is the last slide already. For those who listening through the sessions, thank you so much for your patience. I will end the sessions for those who are watching the replay, and thanks a lot for those who dial in live and just listening to me for talk. I will just go through a few of the comments and do a bit of chit chat so that I cover all the comments here. So that's the end of the presentation already.